Okay, now let us move to this question. Now this question, as you have a glance at it, it is related to circular motion, right? So as we teach students in circular motion, there are a lot of concept related to vertical circular motion, right? So we discuss a lot of things, that what velocity will sustain the circular motion, but we also discuss that what kind of velocity will not sustain the circular motion. So if the velocity at the bottom in string mass system is less than root 5 gl, so the circular motion won't complete. If it is more than root 2 gl, it breaks somewhere here. Okay, it breaks somewhere here. Let me just, okay. Hmm. So it breaks somewhere here, and the speed is less than root 2 gl, it breaks somewhere here. Now, as you can see, this question already points out that the circular motion is breaking over here. Now, how do we find out? Because why it will break, that also they have mentioned. Because the string slacks. Slacks means tension goes to 0, right? So what we need to do? We will draw a free body diagram using tension equal to 0. We will relate the velocity, and then we will relate that velocity with this V naught using energy conservation. Okay, so these are the two equations you need to write. Okay, so let us see. First we will write the equation over here using free body diagram. So what does the free body diagram tells us? Now whatever angle theta is given, we will write in that term. So this is theta. Then we have mg, which is vertically downward. Then we have a tension which is approaching to 0, it seems over here, right? Then you apply that, it might have some velocity from over there, but may not be that much sufficient. So surface, the tension has become 0. So mv square by L, let's say mv square by R. So this is my free body diagram, right? Let us analyze this. This is theta, then this will be theta. Let us approach in radial direction. What are the things? Okay, so if this is theta, this is 90 minus theta. So mg cos 90 minus theta means mg sin theta must be equal to mv square by L. That's why the tension has become 0. Usually you will write T plus mg cos 90 minus theta, which is sin theta, is equal to mv square by L in any position, right? But here what is given? The string goes slack, the tension goes 0, right? So this is our one equation. As you closely look at it, m will get cancelled in this. You will get g sin theta is equal to v square by L. We will use this. Okay, so let us see. Now, how do we relate the velocity over here, which is v, with v naught? So as you know, we can relate it by, energy conservation, that of course there is a gain in potential energy, so there will be loss in kinetic energy. So if you are okay, I will write in terms of gain and loss. So what is the loss in kinetic energy? Loss in kinetic energy, that should be equal to gain in potential energy. So as far as potential energy is concerned, you have to find out the height. Okay, so you have to find out the difference of height from here to here. As you can clearly see, this is theta, this length, if it is L, this length will be L sin theta, and this is L. So it is total height H is L over here and L plus L sin theta over here, right? So what will get there? Potential energy, increase in potential energy. If you consider either here 0 and potential energy there to be something, or you simply write increase in potential energy, and that is equal to mgh, and mgh being mg into L plus L sin theta. So if you have reached till here, that's a good job, right? Now let's see what is loss in kinetic energy. Loss, when we are saying, that means initial is more than the final. Loss, we will write initial minus final. So we'll write, oh, loss will be half m v naught square minus half m v square, right? So here it is v naught and final it is v. So this is our loss in kinetic energy. Okay, remember we are not writing change, we are writing loss, right? Now again what we'll do, we'll cancel m, so and we will manage this thing. So we'll get v naught square minus v square is equal to this 2 over here. We'll get 2g L, you can take common from here, you will get 1 plus sine theta, right? Then what we have to find out? The ratio of v and v naught, right? So we'll solve for v from here. Okay. So you see here V is equal to GL sine theta, right? V square equal to GL sine theta, right? So let us divide it by that factor. Okay, so we'll divide this factor over here. You will get V naught square by V square minus 1 is equal to, and this side will divide it by GL sine theta. Similar terms divided with similar. So you'll get 2 GL will get cancelled and you'll get 1 plus sine theta by sine theta. Okay. Now this will be your ratio. It will be like, so you'll get 1 over here plus 2 plus 2 sine theta divided by sine theta. All you have to do is consolidate this term. What you will get? Sine theta 1 more, sine 2 sine theta plus sine theta 3 sine theta. So you'll get 2 plus 3 sine theta divided by sine theta. Let's try to manage with, what are the options? Okay. So what is the ratio we got? We got 2 plus 3 sine theta divided by sine theta, and we have got the ratio as a square, right? So that's why the answer will come as 4. All right. So that is related to vertical circular motion, and the circular motion is breaking because of not having sufficient speed or not having sufficient kinetic energy. Okay.